So here we see angular displacement in action. The real definition of angular displacement is the angle through which a point, line, or body is rotated about a specific axis in a given direction. Because that is a bit confusing, there's a distance an object moves, so the distance an object moves when following a circular path represented by the length of the arc of a circle drawn to represent the motion of the object about a fixed point. Now that makes no sense because we haven't reviewed anything about circles. First of all, a circle is round. A circle has a circumference, which is the area around the circle, around the outer edge. Circles also have a radius, which is half of the diameter all the way through. This is the arc length. So if you take a chunk out of any part of a circle, you're going to have the arc length. Arc length is represented by an S. Radius is represented by an R. And the angle of the piece that we took out is represented by theta. Theta is a Greek symbol, and it's usually measured in radians. Angular displacement is also measured in radians. Now, because we don't use radians on a regular basis, radians can be configured using degrees. So you take the degrees, and you multiply by pi over 180. You simplify, and it gives you radians. So we measure angular displacement by saying theta, our angle, equals S, which is the arc length, over R, our radius. So we take theta, and we divide the arc length divided by radians, and that will give us our angular displacement. So say we want to find the angular displacement of this arrow. The arrow starts at the top, so here's our starting point, and then we spin. Our spinner ends there. So our angular displacement is all the way around here. So the way we measure that is with our protractor, and you measure the angle, you measure this arc length right here, and you divide both of them, and that will give you your theta.